if we wanted to solve a system using the substitution method, let's look back at how I did this. I first had this equation written as y equals stuff. That stuff over on the other side of the equation is the value I plugged in for the y on the other equation. In order to do this, though, I had to have that first equation solved for y. In this instance, neither of these equations are solved for a variable. But I'm noticing this variable right here doesn't have anything multiplied by it. Well, I guess it's, it's subtracting. But there's no 2 or 3 or 4, anything like that in front of this y. So if I solve for this y, I don't need to divide by anything. So if I'm going to use the substitution method here, I would like to solve for this y. That's what I'm going to do here. I'm going to solve the first equation for y. Like I said, the reason I'm doing that is because the coefficient here is a 1, or, well, in this case it's a negative 1. But it turns out a negative 1 is not really that much different. All right, so we have 2x minus y equals negative 15. I want to solve this equation for y, which means I want to subtract 2x from both sides, giving me the opposite of y equals negative 2x minus 15. And it's not quite solved for y yet because I have the opposite of y over here. I need to get rid of that, so I'm going to divide both sides by negative 1, giving me y equals 2x plus 15. Now that I have the first equation is equivalent to saying y equals 2x plus 15, now I can plug that into the second equation. So the second equation says 4x plus 3y equals 5. This is telling me the value of y, so that thing needs to be plugged in to y. So I get 4x plus 3 times 2x plus 15 equals 5. And I need to solve this because, again, we're in a situation where we have only one variable, so we can figure out what that variable is forced to be. So 4x plus, distribute my 3 here, 6x plus 45 equals 5. Combine like terms, get 10x plus 45 equals 5. Subtract 45 from both sides, I get 10x equals negative 40. And divide both sides by positive 10. I get x equals negative 4. So what I've seen here is that if both of these equations are to be true, the first, the value, the x coordinate must be negative 4. Let's plug this back into this equation where I solved for y and use that to find y. And I'm using the modified form of the first equation. I am kind of making the assumption that I didn't make any mistakes there, but I'm okay with making that assumption. So we have y equals 2 times, well, let's write the equation first. Y equals 2x plus 15. When I plug in a negative 4 for x, I get y equals 2 times negative 4 plus 15. That's negative 8 plus 15, which is 7. So in total here, I said that y is 7, x is negative 4. So that's the point, negative 4, 7. If I wanted to check this, I don't have a whole lot of room on this page, but I'll check it here. Checking it with the first equation. Now, I used this equation here that I solved for y there to find the value of y. But when I'm checking something, I want to go all the way back to the very original equation because I want to minimize the chances that I made a mistake, or basically, the whole point of checking your work is to see if you made a mistake. So I want to go back and plug it into the original equation, where before any changes have been made, to guarantee that if there were any mistakes made in here, they should cause a problem. So checking with the first equation, that's 2x minus y equals negative 15. When I plug in, let's see, negative 4 for x and 7 for y, I get negative 8 minus 7 equals negative 15, and that's a true statement. With the other equation, let's see, that's 4x plus 3y equals 5. When I plug in this point here, I get 4 times negative 4 plus 3 times 7 equals 5. That's negative 16, should be a question mark, plus 21 equals 5, question mark, and that's a true statement. So you can see this point right here, this is the point that I found, that does actually satisfy both equations, and I verified that it satisfies both of those equations right here. So the point negative 4, 7 is the solution to this system of equations.